My name is Daniel Kipe and I am a game design student at FullSail University. Obviously, I'm taking the online courses, probably just like everybody else in this class. It is November 2014. I am in the conceptual physics class with Corin Rombach, and what I'm doing my video and simultaneous demonstrations on are Newton's laws of motion. This first law of motion states that every object continues in a state of rest or of uniform speed in a straight line unless acted on by a non-zero force, which means that if this 2.5 pound plate were to just sit on my counter as such, unless I were to touch it, move it, or somebody else were to, it would stay at rest indefinitely. If it were in motion, however, such as it attempting to roll in a straight line, it would stay at motion until something else were to come along, kick it, poke it, pick it up, or throw it around, or any other force like that, because that's a force. This law is also called the law of inertia, the law of inertia, because since things don't change motion, such as this object at rest, without a force touching it, that is the object's resistance to the change of motion, which is also called inertia. On to Newton's second law, which is the acceleration produced by a net force on an object is directly proportional to the net force, is in the same direction as the net force, and is inversely proportional to the mass of the object. In other words, I'd write it down for you. It would say acceleration is similar to net force divided by mass, or net force over mass. So again, I take a single 2.5 pound plate, I set it on my counter, it's at rest, which is the first law. For the second law, I'm going to use my hand as the outside force to move it. If I push it this way, it's accelerating. No duh. Now if I take two hands, use the same amount of mass, this little 2.5 pound, the weight here, and I push, I have just now double the amount of acceleration of the object. Now if I take two 2.5 pound plates, I push with one hand, like I did with the other plate, I will have, in the end, half of the acceleration that I did with one plate. Now if I take twice the amount of force, meaning two hands, and twice the amount of mass, two 2.5 pound plates, and I push them, I have done nothing to the acceleration other than kept it the same as when I was using one hand and 1 pound plate. In the end, everything's proportional. If you have double the weight, the double acceleration, it'll do nothing as if you had a smaller amount of weight and acceleration that were proportional to each other, which means the same. His third law is whenever one object exerts a force on another object, the second object exerts a force that is opposite and a direction that is opposite to the first object. Back to my two 2.5 pound plates. If I push them together with the same amount of force, they will be pushing back at each other with the same amount of force. What's not seen here is the direction that the force is going. For this 2.5 pound plate in my left hand, if I push against it and I push against this in my right hand, the amount of direction, or not amount of direction, the force and direction for the left plate is going to my right. If I push left with my right hand, the direction is going to the right. That explains this third law of motion. Everything is opposite to each other when they are pushing against each other, such as your fingers. Same amount of force, different directions. Now earlier I said I was a game design student, and I can tell you that this will be useful in a game because if you want to make a realistic game, let's say this is a wall, this is my character. My character is running at a wall. It's probably not strong enough to go through that wall. This wall is at rest until acted on by a force strong enough to move it. The character is not strong enough, but my character, my little two fingers here, are my character moving. They are at a constant motion until they run into this wall, which is my force acting against this wall. Against my character, not this wall. As for the second law, if you decide you want to take a boat, put it in the ocean, and you put another boat on top of it, it's going to go slower. But if you put a jet behind that boat, it's going to go super fast. That's it. Third law is pretty self-explanatory.